Hi, welcome to my video. Now, in this video, we're going to do some study planning on how to study organic chemistry. So remember, I'll be doing this video based on what we are being assessed onto, okay? So now we have different types of homologous series that we know under organic chemistry. So we need to study all of these homologous series to prepare ourselves for examination. So now what you see over here, this is the first slide of our organic chemistry second semester. So now this is what is happening. In this first slide, I'm not going to discuss a lot. I know we need this slide as well. The reason being is that the slide that I'm going to discuss is the next slide where it starts with alkenes. Why I'm not discussing a lot of this, like I said, we need this. This will cover at the end of everything that we need. We have a lot to cover. I think it's about 17 chapters or so, 17 slides or something like that. So we need a lot from these slides. So now this is what I'm going to do. I'm going to quickly go through this slide, okay? I'm not going to dwell too much on the slide, like I said, and I'll be explaining why. What's the reason for me doing that? I just want to familiarize yourself with something. Now, under this slide, okay, we are looking at the alkanes and the cycloalkanes. And then again, there are so many things that we need here. Let's have a look at, let me do this. We've discussed this, the orbitals. We talked about the orbitals of organic compounds, and then we talked about the electron shell, the electron configuration. We know this, how to draw electron configuration of organic compounds. And then again, if you are given an element, you use the atomic number of an element to draw an electron configuration. And another thing that we have learned, it's the development of chemical and bonding theory. Here we spoke about different shapes of organic compounds. We have the tetrahedrons shapes. We have even in physical chemistry, not physical chemistry, even in I think other modules we've learned on how to actually give the molecular shapes or the geometry of organic compounds, right? Based on the angles between, or here, even in organic chemistry, we also learned about that, and nature of chemical bonds and all of that. We spoke about the Lewis structure. Again, we need to know how to draw a Lewis structure of organic compound. Different, not only organic compounds, even inorganic compounds, different compounds. I saw that we also sometimes they task us on that, on how to draw the organic the Lewis structure. And here are the Lewis structures. And then the formation of bonds between the two consecutive atoms. We know that it's covalent bond. More especially here, we are dealing with non. Sorry about that. More especially here, we are dealing with non-metals. We know that the bond between the two atoms will be what you call the covalent bond. These bonds are very important because we also talked about the hybridization. Okay, I think there is a video here, you can go check it, whereby I was explaining a hybridization. How does a hybridization actually takes place? And then here we talk about the hybridization of methane as P3 hybridization, which is the combination of the orbitals. And then here, the models on how to do a hybridization, the structure of the methane. And then, yes, it continues. Now here we're talking about the structure of ethane. Remember, the reason why I'm doing this is because I want to cover what we are being assessed onto, okay, which weighs a lot of marks. So we're gonna ask ourselves only 3 questions, but I'll show you how. Just want to go through this slide quickly browsing through it. Just you familiarize yourself and remember what is actually on this slide, because we need to start from the beginning till the end. So here we have the hybridization again of ethane. It's a repetition just to emphasize on how the hybridization actually takes place and the energies that are involved during that. And then we have other kinds of hybridization, sp2 and sp of ethylene and ethine. It's ethine or ethane. I don't know how you want to pronounce it, but it's ethine. And then the other kinds of hybrid orbitals, sp2 and sp3, sp2 and sp. We have already spoke about that and all of that. And then these are all hybridizations, okay? And then there's an exercise to task yourself, how well do you understand all of these questions, how to spot out for the hybridization, whether it's sp1, sp2, sp3, and so forth. And then these are exercises. And then the isomerism and the nomenclature, meaning the nomenclature of these organic compounds, which are called the alkanes. So this is also important, the naming of organic compounds. And then isomerism. Isomerism, it actually refers to two different organic compounds that has the same molecular formula. And then they can vary in structures, they can vary in lengths and all of those things, but they have the same molecular formula. We all know that. Um, we need to know how to understand the isomerism, how actually isomerism actually works, and all of that. Here we're still talking about the isomerisms. Uh, um, it's still isomerisms here. We all know that. And then we know we have under alkanes. We discussed two types of in fact, you'll see that when you do stereochemistry, we have the constitutional isomerism and we have the stereo isomers. That depends. That depends on the how the molecule actually, the two molecules are actually being presented. Like I said, we're not gonna go too much on that. We really need to cover what we are being assessed on first. That weighs a lot of marks, and then we'll come back to these things. There's nothing about these things. And over here is nomenclature of branched chains and so forth. Branch chains, the cycloalkanes, the naming, remember the nomenclature, the IUPAC naming of these. And then again, this configuration is very important, cis and trans, how to spot that this organic compound, when naming organic compound, you need to be able to spot it, whether it is a cis, whether it is a trans. There is a formation that we have learned so far. Like I said, we'll come back to these things. And then again, stereochemistry does also play a very important part when naming organic compounds, whereby we're going to use those RNS configurations when naming the organic compounds. But we'll also get there as well. And therefore here it's cis-trans isomerisms in cycloalkanes. And then we have also learned about the conformation. Don't forget that the conformation, there are different types of conformations, more especially for the for the alkanes. The very important one is the one that where we use a Newman projection. We know that we're gonna have Gooch projection, anti, all of those things we have learned. I saw on this slide they're not there, but I'll try when I come back to these things. I'll try to cover them, um, the the confirmations, okay? Because I saw on these slides they are not there, but I'll try to give elaboration on them. And then these are confirmations of the cyclohexane and all of those. We'll come back here. How do these? Sorry, this is naming of. Sorry, this is the naming of the confirmations. How do you see them, these confirmations, the differences of these confirmations and all of that. We're still under alkanes, and then we are done with it. That was just a quick review. I'm doing this because you are studying with me. I know what I'm doing. Maybe this will also help you. Now, what we're gonna do is we're gonna discuss the alkenes moving forward. I spoke about 3 questions. Let me show you what do I actually mean when I talk about the 3 questions, okay? All right, this is what I actually want to show you, okay? Starting from the alkenes, moving to other homologous series. This is what we're gonna do, okay? Let's take the raceme alkene, the one that we're gonna start with, okay? So we're gonna take an alkene, right? We're gonna take an alkene, and we're gonna ask ourselves only 3 questions. The first question is the IUPAC naming of the alkenes, okay? The IUPAC naming. The second question that we're gonna ask ourselves will be the synthesis of alkenes. And then the third question that we're gonna ask ourselves will be the reactions of alkenes. Okay, the reactions of alkenes, and then here's the synthesis of the alkenes. Okay, so these are only 3 questions that we really need to master by the end of these slides. So now you want to ask me this question: why are we not going to ask ourselves based on let me do this, why are we not going to ask ourselves based on the alkanes? Remember, under the slide of alkanes, remember, I'm doing this video for things that we are being taxed onto, okay? So this is the reason why I'm doing this video, because we all struggle. I know the students, we all struggle with this module, especially because it has a lot and we really do not have time. So the alkanes, they're gonna be through other homologous series. You will see. I'll tell you how. Now, the reason is under the slide of alkanes, we saw that we did the conformations, we did hybridization, we did on the previous slide, the slide that I was just showing you now. Those are the things that we actually spoke about under the alkanes. So now we are moving to the alkenes. Now, this is what you're gonna do. We need to know how to name the alkenes. As much as I told you, we also need to know how to name the alkanes and the cycloalkanes. Again, we need to know how to synthesize the alkenes. Again, you want to ask me how to synthesize the alkane. No, I said the alkane, you will see, okay? As time goes by, work will be much more shorter. The other slides will have fewer notes, but I'm going to do some notes, and I'm going to share the notes that I'm going to do with you, which is very simple and quick, okay? To always remember these things. So we're going to do the synthesis of alkanes, how to synthesize the alkenes, okay? Also, they involve the reactions. We're gonna learn the reactions that we're gonna, how many reactions are there? How do we synthesize the alkenes? What are the reagents? We are done. And then we're also going to talk about the reactions of alkenes. These are also the reactions. We're also going to talk about the reactions of alkenes. After synthesizing an alkene, the alkene will undergo a reaction, right? To do what? To form certain organic compounds or inorganic compounds, whatever the case may be, we'll see as time goes by. So that means after synthesizing the alkene, we're going to take the very same molecule that we have just synthesized, and we're going to react with a certain species to form another product, okay? So our lecture, what I've realized is these are the questions that weighs a lot of marks, but the most one that carries a lot of marks, it is the synthesis and the reactions. So this is the reason why I'm doing this video, okay? I'm not gonna start with IUPAC naming. I'm just going to start with the synthesis and the reactions of all homologous series that we need. And then by the end of this chapter, let's make sure that we understand the synthesis, we understand the reactions of the synthesis, we understand the reagents that are needed for the reaction to take place, or the catalyst, or whatever the case may be for the reactions to take place. Same applies to here, okay? So we're also going to move to an alkyne, we're going to move to haloalkane, alcohols, esters, carboxylic acids, all of the homologous series that we need to study. We're gonna ask ourselves the very same 3 questions, but again, I'll always start from the synthesis, the reactions of alkenes, and our answers will be answered. So after each and every slide, probably we'll try to do some tutorials based on each and every slide. For alkene, we do tutorial. We do haloalkane, we do its tutorial. Alcohols, we do its tutorial to see whether we understand or not. So yeah, that's how we actually going to break this module down, because I realize we really don't have time and we have exam approaching anytime soon. So that's how our lecture actually assesses us. We've seen from the semester tests, we've seen from the class tests. So that's how we're not going to dwell too much on the mechanisms. The mechanisms are actually there to help us to see how does the reaction actually takes place. So he taught us mechanisms, but the mechanisms are not that very, very important, because he never assesses us on mechanism. So I think he wouldn't, even in exam, he wouldn't want us to fail. So he would most probably give what he has been giving for semester tests. Let's hope he'll also give everything that he gave us on the class tests. You can learn your mechanisms if maybe you are covered with this, to see how does the mechanisms actually work. It's very nice and it's very easy to understand the mechanisms. And when you understand understand the mechanisms, it will make sense to you for you to see how this reaction actually are taking place. So stay tuned. After this video, I'll most definitely do another video based on now the content that we really actually need to focus on to. Thank you.